Greetings everyone, this is Maximilian from Prismatic Realms, and in this video, we'll be taking a look at PRState, our lightweight finite state machine extension that you can use in your GameMaker Studio 2 projects. We'll be mocking up this little demo featuring everyone's favorite blue bomber, Mega Man, as well as one of his little enemies, Metall. PRState was used to implement most of their behaviors. There they are, doing their thing. If you're a GameMaker Studio 2 user, and you've purchased the PRState extension and would like to follow along, you can download the starter project using the link provided in the description below. If you're interested in learning more about PRState or would like to make a purchase, you can find those links in the description below as well. Let's get started. We'll begin with this starter project that I've put together. It contains all of the required sprites for the Mega Man and Metall characters, as well as a simple room for them to play in. The first step is to import PRState into the project. There are a couple of ways to do this and it depends on where you've purchased PRState from. If you bought it from the Yo-Yo Games marketplace, then you'll find PRState in your library. This way, it's just a matter of opening that up, selecting PRState, and going through the import process. If you bought PRState from another vendor like Itch, then drag the package from your operating system into the GMS2 window and go through the import process as before. Once imported, you will find PRState within the PR modules group. We'll start off by creating the Mega Man object. Assign the idle sprite. Open the parent window, and drag the PRState object there. The Mega Man object is now a child of the PRState object and inherits its implementation. Now that the Mega Man object is a PRState object, let's add his first state, the idle state. Begin by inheriting the parent object's create event. Call the PRState method to add the new event. We've specified idle state as the method that will be responsible for implementing this event, so let's add the method now. A code snippet is included in this module to help simplify the process. Let's copy and paste it into the object's create event. Remember to replace the method name with the one we chose to represent the idle state. Let's take a brief look at this method before proceeding. The first if block will be responsible for handling the state's initialization, which is called once when the state is initially set. The second if block can be used to perform any needed cleanup and is called once when the state is about to switch out to another state. The rest of the method's body will be responsible for implementing the state's logic at every frame. Let's continue implementing the Mega Man object's idle state. The idle state doesn't do very much, but we know we need to set Mega Man's sprite to his idle sprite every time the idle state is set, so we'll insert the code needed to do that into the initialization block. Let's also set the Mega Man object's initial state, so that the idle state code begins running right out of the gate. So, let's place Mega Man into the room and see what we've got if we run the project. Like I said before, not much, but in the next section, things will begin getting interesting. Let's add Mega Man's blink animation to his idle state code. First we'll define a couple of constants that define the eye blink open and closed times, and a property to keep track of the current blink time. Now we'll write the blink handler code. This will run at every frame. The idea here is that every time the blink time counts down to 0, we want to swap between the idle and blink sprites. When we do, we reset blink time to the appropriate time for the sprite being displayed. And here is where we decrease the blink time property. Let's not forget to initialize the blink time property in the initialization block, so that the blink countdown begins as soon as the idle state is set. Now let's take a look at some mega blinking action by running the project. There we are. Almost seems human, doesn't he? Let's add another state to the Mega Man object, the run state. First, let's add a constant that defines Mega Man's run speed. To add a new state, just add another PRState call, as we did with the idle state. And again, as before, let's copy that method snippet, and paste it into the event. Change the method name to run state, to match the method name we assign to the new state. Now that we've got more than one state on this object, we'll need a way for one state to transition to the other. Let's add a keyboard check in the idle state update code. If we detect the left or right arrow keys being pressed, we can change the state immediately using PRState. Always remember to exit after changing the state, so that you don't continue running any code below this point from the current state. Let's continue filling in the run state's implementation method. When the run state is set, the initialization code should set the correct sprite. In the frame update section of the implementation method, we'll perform keyboard checks to determine if the player is pressing left or right on the keyboard. If so, we'll adjust the sprite's X position and flip the sprite to point left or right accordingly. And, as with the idle state, we will need a way for the run state to transition back to the idle state when the player isn't pressing either of the arrow keys. Now, let's give that a whirl. It works great. Let's keep it going by adding a third state. We will give Mega Man the ability to jump this time. First, let's define a few properties. First, a couple of properties to define the ground level and gravity. Then a few properties to handle a variable height jump mechanic. After some trial and error, these are the values I've determined that yields good results. Also, let's add a property to keep track of the actual Y coordinate, as we'll be rounding the Mega Man sprite placement to the nearest integer. And finally, a property to keep track of the Y speed. Now that those properties are defined, let's add the new jump state. We're going to actually add two states here, one for the jump up motion, and one for the fall back down motion. While I grab that snippet once again and create the implementation methods for both states, allow me to explain a bit further. There are some logic differences in what happens between both halves of the jump action that could warrant two states. Plus, the added benefit of having a separate fall state is to allow Mega Man the ability to fall from a height that isn't the result of a jump, such as falling from an upper platform. Herein lies the true purpose of a finite state machine, to define clear logical separation between the various object behaviors as you see fit. Okay, so we've got our two method shells, let's hook them up to the other states. In the idle state, we want to transition to the jump state when the player presses the jump button on the keyboard, X in this case. We want to do the same thing in the run state, as Mega Man should be able to jump while running too. let's collapse some of these methods down for the moment. We're going to fill in the jump state method now. By now we should have the hang of this. When the jump state is first set, we'll definitely need to set the jump sprite. We'll also need to initialize these properties to begin the jump mechanic. In the update section of the method, we will implement the logic needed to get the jump working. First, we'll check if the player is still pressing the jump button, and if there is power left to draw from. If so, we'll decrease the jump power reserve. Commenting is always a good idea. If the player has let go of the jump button, or if the jump juice has run out, we want to switch states to the fall state. Now let's write the bit of logic that calculates the jump movement speed and applies it to the object's Y position. Okay, let's run the project and see what we've got. Well, it seems that Mega Man thinks he's in an old Toyota commercial, but this makes sense. We've only written the logic that handles the first half of the jump motion. We'll look at the second half in the next section. Let's get Mega Man's second half of his jump action done now, by filling out the fall state implementation method. You know the drill. Let's set the fall sprite in the initialization block. Falling uses the same sprite for jumping. In the update section of the method, let us check if there is any power left in the jump tank. If so, deplete it at a quicker rate to give us a bit of an arc at the top of the jump. And, as with the jump state, let's write the code to calculate the falling movement speed, and apply it to the object's Y position. Commenting is a good thing. Now, let's write some code to check if Mega Man touches back down to the ground, so that he doesn't go through it, like some schmuck. We use PRState to transition back to the idle state when he hits ground. Note that we hard-coded ground level here for the sake of brevity. Normally, you'd be implementing tile collisions in a game like this, but that is beyond the scope of this video. Let's run the project and see what we've got. Not bad. Looking good. Small jumps, bigger jumps, not bad at all, but you'll notice that although we can jump, even when running, Mega Man does not move laterally while in the air. We'll fix that in the next section. We want Mega Man to be able to move left and right while he is in the air. If you recall, we had already written code that allows him to move left and right in his run state. We can use the same code in his jump states, but rather than duplicating this logic a bunch of times, let's place it in a new method that can be called from multiple places. We'll return false from this method if left or right was not pressed, so that the run state can detect if it should switch back to the idle state or not. Let's add that new method called to the jump state. And, to the fall state. That ought to do it. Let's have a look. Fantastic. Mega Man is now completely breaking the laws of physics, and it is glorious. Let's move on and give the little guy some firepower. If Mega Man is going to fire his arm cannon, he is going to need a bullet, so let's create one now. Assign the default sprite, and assign PRState as the parent object. Once again, let's copy that snippet and paste it into the bullets create event. This method will be responsible for implementing the bullet's one and only state. Well, why are you deriving from PRState if the object's only got one state? That's what you must be asking yourself. Well, I'll tell you why. In my experience, it is rare for an object to have a single state. Objects live and objects die. That's two states right there, and you might want the object to do something for both. That right there is a recipe for using a finite state machine. Even if it's not apparent right away, it may become apparent later. So it's nice if the object is already set up to handle multiple states. How was that for an explanation? Okay, so we've got our implementation method shell for Mega Man's bullet fly state. Let's start filling it in. Let's define a couple of properties that keeps track of the bullet's direction and speed. Notice that we have purposefully not assigned a default state to this object in the create method. More on this later. In the initialization section of the method, we're going to initialize the direction property in an interesting way. We are going to use the PRGetStateData1 method. Use this method to pass a discrete parameter to a state. There is also a data2 and a data3 method if you need to pass additional parameters. We will see how to pass a parameter to this object when we write the bullet spawn method in the next section. For the fly speed property, we'll initialize it with a constant. So let's create that little bugger. We'll multiply the speed by the direction, so that the bullet will fly to the left when Mega Man is facing left. There are only two things to do in the frame update section of the method. The first is to update the X position of the bullet. The second is to check if the bullet has exited the camera's view, and destroy it. Let's create a separate method that does just that. Let's fast forward this one a bit. All that's left is to call the new method. That should do it. In the next section, we'll look at spawning this bullet object, and how to pass the bullet fly direction via the data1 parameter. Mega Man has an arm cannon, so it's only natural that he be able to fire it. So let's write for him a little method to do so. We'll call the new method spawnBullet. Sounds reasonable to me. The method receives two parameters, a spawn X and Y coordinate where the bullet will be spawned. Mega Man can fire only 3 bullets at one time, so we'll do a check against instance number to determine if a new bullet can be fired. The bullet will be created at the desired coordinates on the bullets layer. We call the bullet's PRState method to set the fly state, passing Mega Man's facing direction as the data1 parameter discussed in the previous section. Finally, we return the bullet object if it was successfully created. We return no one otherwise. Now, in the idle state, let's add a new key handler for the Z key to act as the fire button. It will call our new spawnBullet method, passing it the appropriate X and Y coordinates based on Mega Man's gun position and facing direction. We also set Mega Man's sprite to the one where he is pointing his big gun. What do you say we fire off a couple of rounds? Not bad. The bullets are working, Mega Man's stance is working, but he isn't resetting himself back to his idle pose after firing. We'll take care of that in the next section. Mega Man's shoot pose is only partially done. What we'd like is for Mega Man to point his weapon when he shoots, and stay in that pose for a few frames, before reverting back to his very dashing idle pose. Let's add a property to keep track of this pose time. And a constant defining how many frames Mega Man will hold that pose. When Mega Man shoots, set the pose property to that constant to begin counting down. Decrease that property, and then check if it's reached 0. If so, set the sprite back to idle. That's all there is to it. Let's check it out. Very good, exactly what we want. But there is still an issue. That shoot pose doesn't carry over when Mega Man state switches from idle to another state, like the jump state. We would like for him to continue pointing his weapon for the full count, regardless of which state he switches to. Looks like there is a little more work to be done. We'll address the shoot pose carryover between states now. The idea is that when Mega Man state switches from one to another, the new state should recognize whether or not Mega Man is still in his shoot pose. If he is, then we should display the sprite where he is pointing his weapon. Otherwise, we should display his normal sprite for that given state. Luckily this is easily done. Let's get to it. First, let's make the change to the run state initialization code. Believe it or not, that's all that was needed. That one is done. Let's move on to the jump state, and make a similar change there. Done. Another one bites the dust. One more to go. This time, in the fall state. Let's hop to it. Alright, finito. Let's take a gander at our handiwork. Great. Mega Man continues to point his weapon when he jumps immediately after shooting. We're almost completely done with the shoot pose. We still need to implement the ability to shoot while jumping and while running. After that, we are done with the shoot pose, I promise. On to the next section. In the last section, we made Mega Man's run, jump and fall states aware of the shoot post time property to display the correct sprite in their initialization blocks. But what we haven't done yet is have those states decrease that property at each frame should that property be greater than 0. Let's perform this simple task now. The idle state already has this code, so let's copy it to the other states. When the property reaches 0 here, we want to display the standard run sprite. Let's do the same thing in the jump state, being sure to show the normal jump sprite when the property is 0. And one more time in the fall state, the normal jump sprite will be used here as well. Okay, let's run the project and have a look. It doesn't look very different from what we did in the last section, does it? I'm afraid I have a confession to make. Remember when I promised that this would be the last shoot pose change? I'm afraid that wasn't entirely correct. We've implemented the shoot pose transition from state to state, but we haven't yet given Mega Man the ability to shoot mid-jump, nor while running. We'll tackle that next. Let's finish with the Mega Man object states by giving him the ability to shoot while running and jumping. We already have a shoot handler in the idle state, so let's copy that. Paste it into the run state and adjust the bullet spawn coordinates, and display the correct sprite image. Let's copy that and paste it into the jump state. Again, adjust the bullet coordinates to match the new pose, and display the correct sprite. Let's copy and paste the code one more time. This time it goes into the fall state. We don't need to adjust anything here because the fall state uses the same sprite as the jump state. Let's have a look at how our finished Mega Man object moves. This is really good. But it looks like we forgot one little thing. The shoot pose carryover from the fall state to the idle state isn't working. As you can see, when Mega Man lands on the ground while in his shoot pose, the shoot pose goes away the moment he lands. Darn it. I thought we were done with that. Let's fix that little bugger and try again. There it is. We had forgotten to display the correct sprite in the idle state's initialization block if the shoot post time was greater than 0. Alright, one more go, for Queen and Country. Much better. Very good. It's pretty close to the original, if I do say so myself. Hopefully, by now, you have a pretty good understanding about how to use PRState to implement a finite state machine. In the remaining sections, we'll add a little enemy for Mega Man to play with. So let's crack on. So, let's add another object to the project representing an enemy for Mega Man to interact with. We'll do this as a refresher, to make certain that we understand how to use PRState. As before, create the object and name it, assign the default sprite and inherit from the PRState object. Let's place little Metall into the room, but first, let's get Mega Man onto the correct layer. There we are. Now, inherit the create event from the parent object, add the idle state, and paste the snippet into the event. Rename the event. And set the initial state. Let's have a quick look at the Metall character sprite. It's got two frames. The first one is his closed form, the other, his open form. So, let's set his sprite image to his closed form by default in the initialization block. That's his basic setup. We'll add more states to Metall in the next section. In the Mega Man game, the Metall character sits idle until Mega Man comes close. At that point he becomes aware of Mega Man and pops open after a short delay. This awareness can be put into a new state. Let's add that now. We'll call it the aware state. Let's bring in that snippet once again, and name it aware state. The aware state's initial sprite image is the same as the idle state, Metall's closed form. In the frame update section, let's begin writing Metall's aware behavior. First, we'll write a little routine that flips Metall left or right depending on which side of him Mega Man is standing. Since we're going to need to reference the Mega Man object via code, let's give his object instance a proper name. Back in our code, we'll check the X position of Metall versus the X position of Mega Man. Depending on the result, we'll adjust the image X scale as necessary to flip Metall's direction. Now we'll add some code to the idle state to allow a transition to the aware state, if Mega Man comes close enough. We can create a constant to define the maximum distance needed for Metall to become aware. We can compare that constant to the distance differential between Metall's position and Mega Man's. If we determine that Mega Man is within range, we change Metall's state to aware. In the aware state, we will do the exact opposite. Let's copy that logic, paste it into the aware method and make some adjustments. Here we want to switch back to the idle state when Mega Man is no longer within range. Now, let's see all of that in action. Perfect. Metall flips left and right as he should. In the next section, we'll make him pop open for a bit, to prepare him to fire his own set of bullets at Mega Man. Let's begin adding Metall's shoot state. First, we'll add the required logic making him briefly open and close. In the following section, we'll actually make him spit out bullets. Let's begin, as always, by adding a new state to the object. Grab that implementation methods template from the snippet, and paste it in. Don't forget to rename the method. When Metall switches to his shoot state, he is in his open form, so set the sprite image accordingly in the initialization block. Now, we'll add a couple of constants that define the min and max range for the delay that occurs before Metall pops open, to keep Mega Man guessing. This new property will be used to keep track of Metall's current time delay. Let's initialize it, in the aware state, with a random value between the range we just defined. When that time delay reaches 0, we want to transition from the aware state to the shoot state, which is when Metall will have a nasty surprise for Mega Man. Let's not forget to decrease the pause time property at each frame. Let's check our work so far by running the project. Approach the enemy. And, voila, Metall pops out to say hello. Of course he stays that way because we haven't yet programmed him to close up. Let's do that now. Define a new constant representing the length of time that Metall stays open while in his shoot state. Then, in the shoot state's initialization, set the pause time property with it. When that property counts down to 0 in the shoot state, we would like for Metall to clam up. In other words, back to the idle state he goes. That should do it. Let's have a look. Approaching Metall. Random time delay. Open and close. Exactly what we want. In the next section, we'll make Metall belch out some lead. In this section, we make Metall shoot bullets. Begin by creating an enemy bullet object. Drag in the sprite for the enemy bullet. Open the parent window, and drag the PRState object to inherit the finite state machine features. Add the bullet's primary state. We will call it fly. Also, set it as the initial state, so that it is active the moment the bullet is created. Let's go and get that oh so useful snippet, and paste it into the bullet's create event. Rename it to fly state. This bullet object will destroy itself when out of view of the camera, just like Mega Man's bullet, so let's go and copy that behavior logic. And paste it into here. We'll come back to this in a sec. Back in the Metall characters object, we will create a new method for spawning his bullets. Yes, we'll need a constant representing the bullet speed first, so let's go back to the bullet object, and add that in. Okay, back to the Metall object. Let's create a stub for the bullet spawn method that we will fill in shortly. Metall will fire his bullets a short delay after he opens up, so we'll need another timer constant, and a property to track the current timer count. In the shoot state initialization, let's initialize that property. And in the frame update section, call our bullet spawn method when that property reaches 0. We should also set the property to -1, to prevent the method from triggering again. Don't forget to decrease the property at every frame, otherwise nothing will happen with it. Now that we've placed the call to spawn bullets in the shoot state, let's go and write the implementation for that method. This method will spawn 3 bullets at once. We will create each bullet using the instance create layer function, placing them onto the bullets layer. These bullets will use GameMaker's built-in properties to handle their speed and direction. The bullets will travel either left or right depending on Metall's facing direction, thanks to a quick peek at his ImageX scale property. The code to create the second bullet will be mostly the same, though we'll alter the trajectory to obtain a slightly upward motion for this one. The third bullet will be similar, but will travel in a slightly downward motion, so we'll set the direction property accordingly. That should do it. Let's give it another go. Mega Man, approaching the enemy. Bam. Other side. Bam. Looks good. Wonderful. We are nearly there. In the next section, we'll implement some collision detection and allow Mega Man to kill poor little Metall. We shouldn't allow Mega Man to stand for this insurrection mounted by Metall. Let's allow for Mega Man's bullets to kill the enemy. In the Mega Man bullet object, add a new collision event against the Metall enemy object. In the body of the event, let's write some simple code to inform the enemy that he has been whacked. We also destroy the bullet. Let's take a quick peek at the explosion animation that will play when Metall is killed. Psychedelically repetitive. Let's create an object so we can instantiate that animation. Drag the explosion sprite into the object. We won't inherit from PRState for this object as it is an extremely simple one. It is a play once and destroy type of object. Let's do exactly that. First, add a create event and define a property to keep track of the previous image index. Now, create a step event and check this out. I learned this one during a trip to Honduras recently. If the image index ever becomes smaller in value than the previous image index, that means the animation has started over, and we should destroy it. That's it for this object. Told you it was a simple one. Now, let's implement the hit method in the Metall object. Metall should be killed only if he's popped his head up, in other words, his shoot state. We can use the PRState method to determine what state he is currently in. It will return the current state name. If Metall is in the shoot state when hit with Mega Man's bullet, we instantiate the explosion object and obliterate the little tyke. Okay, we should now have a working collision detection system between Mega Man's bullet and Metall. Let's try it out. Okay, bullets are getting destroyed when hitting Metall in his closed form. And Metall dies if hit when exposed. Splendid. Great going. We've only got one more section to go. In the next section, we'll respawn Metall shortly after dying so that he can come back to taunt Mega Man over and over. Let's finish up this video with one final change. We will add a Metall spawner, so that Mega Man can continuously send him back from whence he came. Let's create a new object which we'll call the room controller. And place it into the room. Just like that. We'll add a create event to this object and define a spawn Metall method. When called, this method will start an alarm that will trigger after a random time. And in that alarm, which we'll define now, we will respawn Metall at a random location in the room. Finally, in the hit method we created earlier in the Metall object, we will call spawn Metall when Metall dies. Since spawn Metall is a room controller method, we reference it via dot notation. So let's give the room controller instance a sensible name. And that right there is the final piece of code we will write in this video. Let's run this project one last time. Cool, hot, and other adjectives people might be using today. And there you have it. That's as far as we'll take things in this video. If you were following along with the starter project and have made it this far, then congratulations. If you had a good time with it, and would like to continue on your own, then I urge you to try adding a couple more states to the Mega Man object. Try adding his single step action. Or, if you are feeling more adventurous, try adding his death state. Or how about having Metall drop a pickup when killed? There are a few extra sprites in the starter project to get you started on these. I hope that you've gotten a good feel for how to use our PRState extension in your GameMaker Studio projects. Perhaps you learned a few other things in the process. Please refer to the links in the description below for additional information on this product, as well as for our other extensions. Feel free to drop us a line if you have any questions. Thanks for watching. Maximilian from Prismatic Realms, signing off.